Hello everyone. In this video, I'm going to go through our lesson on rectangle properties. And the first thing I would like to do is list out what those rectangle properties are. Rectangle properties. So one thing we should note is that a rectangle, really, rectangles are a special type of parallelogram. The rectangles are parallelograms. So all of our characteristics of parallelograms are true for rectangles. This means the opposite sides of a rectangle are parallel. Opposite sides are also congruent. Also, in a parallelogram, opposite angles are congruent. So opposite sides are congruent and opposite angles are congruent. And consecutive angles, meaning angles that share the same side, consecutive angles are supplementary. And lastly, or not lastly for rectangle properties, but lastly for parallelogram properties that are also true for rectangles, diagonals of a parallelogram and therefore diagonals of a rectangle bisect each other. So these 5 properties here are true for all parallelograms. Which means they are true for rectangles. So what are properties that are true specifically to rectangles? Rectangles contain 4 right angles. So each angle is a right angle in a rectangle. And the diagonals actually, besides bisecting each other, diagonals are congruent. So these 2 properties here are true for just rectangles. So any shape that is a rectangle has these 2 green properties as well as the properties that are true for parallelograms. So let's draw a diagram here of a rectangle. Hopefully you know what a rectangle looks like in general. So this is going to be my rectangle A, B, C, D. I might scooch it down just a little bit. Oh no. Ruh-roh. Okay, well, that's fine. We can live with it this way then. We know the opposite sides are parallel. So AB and CD are parallel, and BC and AD are parallel as well. Opposite sides are also congruent. So AB and CD are congruent to each other, and BC and AD are congruent to each other. We also know that those opposite angles are congruent, right? So B, D, and D are congruent. A and C are congruent. However, I can say a little bit more about the angles than just that, right? We actually know that this shape contains 4 right angles. So each one of these angles is a right angle. So naturally, of course, angle B and angle D are congruent, and angle A and angle C are congruent. They're all congruent. They also are consecutive. These consecutive angles are supplementary. I could say if I add A, which is 90 degrees, plus the measure of B, which is also 90 degrees, I get 180 degrees. All right, now let's talk about the diagonals. And I'm going to draw diagonals here, BD and AC, and they intersect at point E. And we know that the diagonals of a parallelogram bisect each other. So AE is congruent to EC and BE is congruent to ED. But actually, in a rectangle, we know that the two diagonals themselves are congruent, which means that each of these little pieces, AE and EC, BE and ED, they are all congruent to each other because AC as a segment, it is congruent to BD. So then we know that all of those little portions that are half of those segments, they're also equal. All right, so how do you know, is it a rectangle? What are some ways you can determine that the shape you are looking at is a rectangle? One way you can determine that it is a rectangle is if you have any quadrilateral with 4 right angles. That has to be a rectangle. Okay, so a little bit more specific. If you have a parallelogram and you know that that parallelogram has congruent diagrams, or sorry, diagonals. So a parallelogram with congruent diagonals, that also is a rectangle. So whether you have a quadrilateral with 4 right angles, you can tell that's rectangle, or a parallelogram with congruent diagonals. The other shape that you know would be a rectangle would be a parallelogram with 1 right angle. So if you know it's a parallelogram, then you know that all of the properties of the parallelogram are true. Oh, I never wrote angle. So the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent. So if you know that this parallelogram has 1 right angle, using those properties, using that consecutive angles are supplementary, you can show them that that parallelogram with 1 right angle actually is a rectangle with 4. Let's look at some examples. So in each of these, we're going to draw the diagram first, and then we're going to answer a question about it. So here is our rectangle of sorts. A, B, C, D with the diagonals BD and AC, and they meet at point B. All right. And then we are going to answer the question in rectangle ABCD. AE equals 4x plus 2, and BD equals 36. Find X. All right, so let's think about this. We know this is a rectangle, and AE, this blue segment here, is 4x plus 2, and then we know the entire length of BD is 36. Well, this is a rectangle, which means that the diagonals are congruent. So this means that the entire diagonal BD is congruent to the entire diagonal AC. And we know BD is 36. So 36 is equal to whatever AC is. The entire segment AC is also 36. Now, let's think about the piece that we know. We know this AE portion, right? This AE, which is half of the entire diagonal. Since this is a parallelogram, I know that BD bisects AC. So AE is congruent to EC, which is also congruent to BE and ED because it's a rectangle and our diagonals are congruent. But now I know really that AE, I could write an expression for AE as 1/2 of AC, right? AE, this little segment that is 4x plus 2, is 1/2 of the whole, which means that it's 1/2 of 36. And 36 divided by 2, or half of 36, is 18. So AE, which is equal to 4x plus 2, is also equal to 18. So now I can simply solve the equation 4x plus 2, because that's AE, is equal to 18. We know AE is equal to 18, and it's equal to 4x plus 2. So we will solve now, and to solve, I will start by subtracting 2 from both sides to get x all by itself. So I would get 4x equals to 16. And we will divide by 4. Oops, I don't like that. 4 times x needs to be undone by dividing by 4, and we will get that x is equal to 4 itself. So x is 4. And that makes sense because if I substitute 4 in for x, 4 times 4 is 16 plus 2, which is 18. And 18, AE plus its congruent half, 18 would give the entire length of 36. All right, let's look at another example. Here is our rectangle. That is so nice that it does that. A, B, C, D. And then we have rectangles. Ooh, ooh, yeah, I knew it wasn't gonna like it. BD and AC. And they intersect at point E. In rectangle ABCD, the measure of angle ABE is 2x plus 4 degrees. And the measure of angle DBC is 3x plus 11 degrees. Find the measure of angle ABE. All right, so we know that angle ABE, which is this angle right here, this is 2x plus 4 degrees. That was my cat. And then we know the other angle DBC is 3. Oh, is that the right angle? Let's see. DBC. Okay, good. Had to double check. That is 3x plus 11 degrees. So these two angles together, let's note this, the measure of angle ABE plus the measure of angle DBC is the measure of angle ABC, right? That forms this entire angle. which in a rectangle, angle ABC has to be 90 degrees. Because ABCD as a shape, ABCD is a rectangle. All right, so this means then that the measure of angle ABE, which is 2x plus 4 degrees, that added on to our measure of angle DBC, which is 3x plus 11 degrees, that has to be 90 degrees. So those two angles will add together to give us 90. So let's solve. Let's solve for what x actually is. And we don't need all of these parentheses. So I'm going to go ahead and just write this as 2x plus 4 plus 3x plus 11 equal to 90. And now we can start combining some like terms. I notice 2x and 3x. That will combine to give me 5x. And then we have our constants of 4 and 11, and 4 and 11 combine to give us 15. So I have 5x plus 15 is equal to 90. And then we can continue to solve, subtract 15 from both sides. So we will end up with just 5x equal to 90 minus 15, which is 75. And then to continue to get x all by itself, I have to undo this multiplication by dividing both sides by 5. So the 5s will cancel, and we're left with x is equal to 15. Now that's not our final answer, right? Our goal is to find the answer of angle ABE. We need to find angle AB. So that is 2x plus 4 degrees. So let's write that back up here. Measure of angle ABE is 2x plus 4 degrees. So now I need to substitute back in that x actually is 15. So this is the same thing as 2 times x, and x is 15, plus 4. And this is again all in degrees. And 2 times 15 is 30, plus 4 gives us simply 34 degrees. So the measure of angle ABE is 34 degrees. Oh. All right, one more problem. Let me pause this real quick. My cat's saying hi. Okay, so now problem number 3. Here is our rectangle. This one's gonna be slightly different this time. Instead of A, B, C, D, this is gonna be P, Q, R, S. And then we have these two bisectors, PR and QS, or sorry, two diagonals, which are bisecting each other. And they form to meet point T. Okay. In rectangle PQRS, PQ is equal to 24 and PS is equal to 15. Find the measure of PR, segment PR, to the nearest tenth. Okay, so here's our rectangle. We know PQ is 24. So this side length here is 24, and PS is 15. Really? And our goal here is to find the length of segment PR, which notice PR is a diagonal. And we know here in a rectangle that diagonals are congruent, which means that PR, segment PR, is congruent to whatever segment QS is, the other diagonal. And I know 15 and 24. So how does that help me? Well, I noticed that actually within this drawing, I have two triangles formed. I have triangle SQP, PQS, however you want to look at it, and then I have triangle RSQ. And these are two right triangles, right? This is a right triangle with one leg that's 15. So this is A here, which is 15, and then another leg, B, which is 24. And our goal is to find what the measure of the diagonal is. And if I find what QS is, if I find this length of C, then I also will know the length of PR, the other diagonal. So really all I have to use here is the Pythagorean theorem. The Pythagorean theorem says that A squared plus B squared is equal to C squared. And we found those things, right? A is 15. So I have 15 squared plus B. B squared is 24 squared. And that is going to be equal to whatever our C squared is. So let's actually simplify this a little bit more. 15 squared. See, that's 15 times 15, and that is 225, which maybe I could have kept that in blue. So 225 plus 24 squared, which 24 squared, that's 24 times 24, that is 576. So I have 15 squared plus 576, and that is going to be equal to C squared. And then if we actually add these two things together, 225 plus 876 gives me 801 is equal to C squared. So if I want to find our actual length of C, I would simply divide by C. Or not divide, what? I was looking at, someone sent a message, I'm so sorry. You would take the square root. To cancel a square, you undo the square by taking a square root, which means that C is simply equal to the square root of 801, which, let's see what that would be. It is 28.3019 ... And we were asked to round to the nearest 10th, which means I don't want any number past this 3. So 0 does not tell me to round up. So this answer is simply, oh, I love that, 28.3. That's the length of, ooh, not C. That's the length of segment QS. Which means it's also the length of PR. Please let me know what questions you have on this lesson.